Howdy AP Chemistry, we're here to talk about photoelectron spectroscopy. This will use the photoelectric effect to basically blast an atom with high intensity photons. And then remember, the photons will eject an electron. And we just learned that that's called ionization energy. So we can blast enough high energy photons to remove all the electrons. When all the electrons are removed, we can actually identify the element. So this is a great way to identify elements, and I guarantee you'll see two or three of these on the multiple choice section. Basically what they're going to be doing is taking a photon source, shining it onto a sample, measuring the angles and all that good stuff, and measuring the intensity, and it will be into a detector that will come all the way back around and analyze the energy, and then back into a detector. Okay, it's a pretty neat little concept, and all you need to do is remember how to interpret the graphs. So the graphs will look a lot like this, and there'll be a straight baseline with a series of peaks. You need to make sure you pay very close attention to the x-axis, because sometimes they order it with the lowest on the left and the highest on the right, or sometimes they flip it and they put the highest on the left and the lowest on the right. I don't know why they do this, but you need to really pay attention to the units. So this one goes from lowest to highest. Don't worry about the units, but it does matter the direction. Another thing that matters is the height of the actual peaks. So the peak of peak 2 right here is a little bit higher than peak 1. You need to look at the intensities right here. The numbers underneath will display the intensities and also the locations. So now the intensity is a 2 right here on the top, and the number down here stands for, it's on 6.26 on this scale. So now the highest energy is going to be the lowest orbital, because that's going to take the most amount of energy to remove those electrons. So this is going to be the lowest orbital, and it has 2 electrons. So as we go to the next slide, it says that the graph below shows the simulated photoelectron spectrum for the element lithium. The electron configuration for lithium is going to be 1s2 and then 2s1. Sorry about my messy handwriting, but notice here that this represents the 1s peak, and there are 2 electrons in it. So see that the intensity is 2, so there's 2 electrons. And then this is the 2s peak, and the intensity is 1, so there's 1. That's basically all you need to do. You can identify the element just based on the peaks. Here's another example, and please make sure to pay attention to the x-axis. Now we have the highest energy on the left and the lowest energy on the right. The reason why they did this is so that the 1s will show up on the left side, since it's going to be the highest energy. So notice that the s peaks are going to be the same intensity, so they're both full. So this would be 1s. This would be 1s2 for sure. 1s2, and then 2s2. And then it would be 2p, let's see, 2p, and then it says 6, okay, for neon, 2p6. You can look at the intensity here and notice that if the area under this curve represented a 2, then it would be, this area under this curve would be 3 times as much. So that would be that would represent the 6 right there. So now give this a try and see if you can what element this is based on the electron configuration and the ionization energy. Well, I see here that it starts, the highest level is on the left, so this is going to be the 1s. And I know that it's the similar peak to this one over here, so that's going to be 1s2. And then this is going to be a 2s2. And then the next step is going to be the p orbitals, and then these are both the same height, so I'm going to assume that they're both full as well. So 2p6, and then it's going to be 3s2, and this is going to be 3p6. And now the last step is this last peak right here, and that's going to be 4s. It's close to 0, so it gives me a clue that it's going to be probably a 4s1. Now notice that it's about half the size of this peak, which is a full peak of 2, so that's going to be 4s1. If I look at the periodic table, the one that has a 4s1 is the fourth group. In the s block, the first one is going to be potassium, K. Alright, thanks for watching.